Okay, class, so just like last week, I'm just going to go through so you know exactly what is coming up on the quiz and just what you'll need to be doing and making sure that you're doing all of those problems correctly. So first thing here, when we look at this, we are talking about adding and subtracting with polynomials. Okay, so this is about combining like terms. So number one here, right, is where we're looking for things that have like terms. It's already addition. So since that 2t squared and negative 5t squared both have an exponent of 2, we can put those together, right? So 2 and a negative 5 gives us negative 3t squared. A negative 7, oops, I can't tell from what I wrote before if that was a, okay, so making sure that was a positive sign. So negative 3t squared. Okay, then we have a negative 7 plus 6, which will give us a negative 1t. You can write that 1, but you don't have to. And then we're looking at, right, the constants that are matching. So a positive 1 and a positive 3 gives us a positive 4. So that's the answer we would put in for number 1. Okay, then let's take a look at number 2. Okay, number 2 is the distributive property. So remember, our rule says that when we distribute, we multiply, and when we multiply, we add exponents. So exponents are just the tiny numbers, the big numbers in front, the coefficients, we still need to multiply. So when we take this 8b to the third times 10b to the third, right, we'll take the 8 times the 10, which gives us 80, and then we'll have a b to the third and a b to the third. We multiply those, we add exponents, so that will give us a b to the sixth. Okay, then we'll go to the next piece, which says an 8b to the third times a 9b. So 8 times 9 gives us a 72. Now, we don't see an exponent on this b, right? But there's really a 1 there. So a 3 plus a 1 gives us a 4. We can't add these or anything, right? Because those don't have matching exponents. So that's just our answer. Take a look at number 3. Number 3 is also the distributive property. So it's the exact same idea as the last problem we did. We just need to make sure that we're doing it 1, 2, 3 times. And remember, when we take this negative 9y to the 6 times negative 6, right, that y to the 6 still comes along with it. Okay, so that negative y to the 6 times negative 6 will give us a positive 54, and that y to the 6 is still with it. So you'll have to get the two numbers that go in front of it, but that's what we do on that one. Number 4, right, we've talked about this, how it looks a little bit backwards, but it's the exact same idea. So for a lot of you, you'll probably just want to rewrite it with this monomial or the 1 term in front. So the negative 4y to the 4th z times 8y to the 5th, z to the 3rd, minus 2z to the 6th. Okay, so if we distribute here, 8 times negative 4 gives us a negative 32. The y's can go together. So 4 plus 5 gives us 9. And then the z's can go together, right? We don't see an exponent there, but there's really a 1. So 1 plus 3 gives us a z to the 4th. And then we're going to distribute to the second piece. So a negative 4 times a negative 2 will give us a positive 8. The y doesn't have anything with it over here, but it still comes along. So we still have a y to the 4th. And then a z to the 1st times a z to the 6th will give us a z to the 7th. That's our answer for this one. Number 5, we have a binomial times a binomial. So remember, we're still thinking about the distributive property. We just have to distribute twice. So the first time we distribute, we're passing out the y, right? So this is going over here to both pieces. So y times y gives us a y squared. Y times negative 4 gives us a negative 4y, right? And then we're going to switch pieces that we look at. So now we're going to look at the second term, this positive 1, and pass it out to each piece. So 1 times y gives us a positive 1y, and 1 times negative 4 is negative 4. And so we'll get a y squared minus 3y minus 4, right? I'm combining these like terms. A negative 4 plus a 1 is a negative 3y. Everything else has to stay because it doesn't have a like term to combine with. Number 6 is the exact same process, right? We're just going to have larger numbers since those numbers both have, since those variables both have numbers in front of it, but it's the exact same idea as the last problem we looked at. 7 is the same idea, but this is where we have the interesting case when we combine like terms, right? So we're still going to distribute the same. W times W is W squared. W times 10 is a positive 10W. Okay, then we're going to distribute the negative 10. Negative 10 times W is a negative 10W. And negative 10 times positive 10 is negative 100. Okay, so just like we were doing before, but now when we combine like terms right here in the middle, a positive 10 and a negative 10 becomes 0. And so all we have left is W squared minus 100. And that's our final answer. Oh, let me switch. Number 8, make sure you are remembering to write this twice. This exponent of 2 here, right, tells us we have to write the u plus 2 twice. And then once we write that u plus 2 twice, we're back to that distributive property, just like we did on the last several problems. Number 9, we have division, right? We said when we're dividing with polynomials, we're really going to just break this up into separate pieces. And we're going to divide each individual piece by that denominator or by whatever we're dividing by, right? When we divide, we subtract with exponents. So we'll do 10 divided by 2, which gives us 5. We're going to subtract the exponents. So 4 minus 2 gives us 2. Then we'll do 14 divided by 2, which gives us 7. And again, we'll subtract exponents. So 3 minus 2 gives us 1. You can write the exponent of 1, but you don't have to have it. It's fine either way. Again, on this last one is the exact same idea. Just remember, this is what it's being divided by. So while we have more terms here, right, we're still doing the exact same thing. You're just going to divide these each individually. Okay, so when we divide here, 12 divided by negative 4 gives us a negative 3. We'll subtract exponents. 6 minus 5 is 1. 3 minus 2 is 1. So again, you could write down that exponent of 1, but you don't have to have it. Then we'll go to the next one here, right? A negative divided by a negative is a positive. And then 35 over 4, we can't really divide, so we're just going to leave that as a fraction. 6 minus 5 is positive 1, so that's z is going on the top, right? When it's positive, it goes in the numerator. And then 1 minus 2 is negative 1. When it's negative, it goes on the denominator. So when you take your quiz, you're going to have the same types of problems in the exact same order. So if you're not sure on any of these, make sure you're practicing, make sure you have them in your notes. You can go back and look at assignments from earlier this week. Otherwise, it will look just like this. If you have any questions, feel free to send me an email. Otherwise, good luck on your assessment today.